Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Here we will learn about different concepts related to civil engineering. Time to enter the world of civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about transportation engineering, cross-sectional elements, pavement surface characteristics. For safe and comfortable driving, four aspects of the pavement surface are important: the friction between the wheels and the pavement surface, smoothness of the road surface, the light reflection characteristics of the top of pavement surface, and drainage to water. Friction. Friction between the wheel and the pavement surface is a crucial factor in the design of horizontal curves and thus the safe operating speed. Further, it also affects the acceleration and deceleration ability of vehicles. Lack of adequate friction can cause skidding or slipping of vehicles. Skidding happens when the path traveled along the road surface is more than the circumferential movement of the wheels due to friction. Slip occurs when the wheel revolves more than the corresponding longitudinal movement along the road. Various factors that affect friction are: type of the pavement, like bituminous, concrete, or gravel; condition of the pavement, dry or wet, hot or cold, etc. Condition of the tire, new or old, and speed and load of the vehicle. The frictional force that develops between the wheel and the pavement is the load acting multiplied by a factor called the coefficient of friction and denoted as F. The choice of the value of F is a very complicated issue since it depends on many variables. IRC suggests the coefficient of longitudinal friction as 0.35 to 0.4 depending on the speed, and coefficient of lateral friction as 0.15. The former is useful in sight distance calculation and the latter in horizontal curve design. Unevenness. It is always desirable to have an even surface, but it is seldom possible to have such a one. Even if a road is constructed with high-quality pavers, it is possible to develop unevenness due to pavement failures. Unevenness affects the vehicle operating cost, speed, riding comfort, safety, fuel consumption, and wear and tear of tires. Unevenness index is a measure of unevenness which is the cumulative measure of vertical undulations of the pavement surface recorded per unit horizontal length of the road. An unevenness index value less than 1,500 mm/km is considered as good. A value less than 2,500 mm/km is satisfactory up to speed of 100 km/h, and values greater than 3,200 mm/km is considered as uncomfortable even for 55 km/h. Light reflection. White roads have good visibility at night, but caused glare during daytime. Black roads has no glare during day, but has poor visibility at night. concrete roads has better visibility and less glare. It is necessary that the road surface should be visible at night, and reflection of light is the factor that answers it. Drainage. The pavement surface should be absolutely impermeable to prevent seepage of water into the pavement layers. Further, both the geometry and texture of pavement surface should help in draining out the water from the surface in less time. Camber. Camber or cant is the cross slope provided to raise middle of the road surface in the transverse direction to drain off rainwater from road surface. The objectives of providing camber are surface protection, especially for gravel and bituminous roads, subgrade protection by proper drainage, quick drying of pavement, which in turn increases safety. Too steep slope is undesirable, for it will erode the surface. Camber is measured in 1 in n or n%, example 1 in 50 or 2%, and the value depends on the type of pavement. The values suggested by IRC for various categories of pavement is given in table. The common types of camber are parabolic, straight, or combination of them. Figure 1. IRC values for camber surface. Heavy, light type, rain, concrete / bituminous, 2%, 1.7%, gravel / WBM, 3%, 2.5%, earthen, 4%, 3.0%. Width of carriageway. Width of the carriageway or the width of the pavement depends on the width of the traffic lane and number of lanes. Width of a traffic lane depends on the width of the vehicle and the clearance. Side clearance improves operating speed and safety. The maximum permissible width of a vehicle is 2.44 and the desirable side clearance for single-lane traffic is 0.68 m. This require minimum of lane width of 3.75 m for a single-lane road, figure A. However, the side clearance required is about 0.53 m. on either side and 1.06 m in the center. Therefore, a two-lane road require minimum of 3.5 meter for each lane, figure B. The desirable carriageway width recommended by IRC is given in table. IRC specification for carriageway width. Single lane 3.752 lane, no curbs. 7.02 lane, raised curbs. 7.5 intermediate carriage. 5.5 multi-lane. 3.5 curbs. Kerbs indicate the boundary between the carriageway and the shoulder or islands or footpaths. Different types of kerbs are low or mountable kerbs. This type of kerbs are provided such that they encourage the traffic to remain in the through traffic lanes and also allow the driver to enter the shoulder area with little difficulty. The height of this curb is about 10 cm above the pavement edge with a slope which allows the vehicle to climb easily. This is usually provided at medians and channelization schemes and also helps in longitudinal drainage. Semi-barrier type curbs. When the pedestrian traffic is high, these curbs are provided. Their height is 15 cm above the pavement edge. This type of curb prevents encroachment of parking vehicles, but at acute emergency it is possible to drive over this curb with some difficulty. Barrier-type curbs. They are designed to discourage vehicles from leaving the pavement. They are provided when there is considerable amount of pedestrian traffic. They are placed at a height of 20 cm above the pavement edge with a steep batter. Submerged curbs. They are used in rural roads. The curbs are provided at pavement edges between the pavement edge and shoulders. They provide lateral confinement and stability to the pavement. Road margins. The portion of the road beyond the carriageway and on the roadway can be generally called road margin. Various elements that form the road margins are given below. Shoulders. Shoulders are provided along the road edge and is intended for accommodation of stopped vehicles, serve as an emergency lane for vehicles and provide lateral support for base and surface courses. The shoulder should be strong enough to bear the weight of a fully loaded truck even in wet conditions. The shoulder width should be adequate for giving working space around a stopped vehicle. It is desirable to have a width of 4.6 m for the shoulders. A minimum width of 2.5 m is recommended for two-lane rural highways in India. Parking lanes. Parking lanes are provided in urban lanes for side parking. Parallel parking is preferred because it is safe for the vehicles moving on the road. The parking lane should have a minimum of 3.0 m width in the case of parallel parking. Bus bays. Bus bays are provided by recessing the curbs for bus stops. They are provided so that they do not obstruct the movement of vehicles in the carriageway. They should be at least 75 meters away from the intersections so that the traffic near the intersections is not affected by the bus bay. Service roads. Service roads or frontage roads give access to access-controlled highways like freeways and expressways. They run parallel to the highway and will be usually isolated by a separator, and access to the highway will be provided only at selected points. These roads are provided to avoid congestion in the expressways, and also the speed of the traffic in those lanes is not reduced. Cycle track. Cycle tracks are provided in urban areas when the volume of cycle traffic is high. Minimum width of 2 meter is required, which may be increased by 1 meter for every additional track. Footpath. Footpaths are exclusive right-of-way to pedestrians, especially in urban areas. They are provided for the safety of the pedestrians when both the pedestrian traffic and vehicular traffic is high. Minimum width is 1.5 meter and may be increased based on the traffic. The footpath should be either as smooth as the pavement or more smoother than that to induce the pedestrian to use the footpath. Guardrails. They are provided at the edge of the shoulder, usually when the road is on an embankment. They serve to prevent the vehicles from running off the embankment, especially when the height of the fill exceeds 3 m. Various designs of guardrails are there. Guard stones painted in alternate black and white are usually used. They also give better visibility of curves at night under headlights. Width of formation. Width of formation or roadway width is the sum of the widths of pavements or carriage. Way including separators and shoulders. This does not include the extra land in. Formation cutting. The values suggested by IRC are given in table. Width of formation for various classes of roads. Road classification. Roadway width in meter plain and rolling terrain. Mountainous and steep terrain. National Highway, State Highway. 12. 6.25 to 8.8 Major District Road. 9. 4.75 Other District Road. 7.5 to 9.0. 4.75 Village Road. 7.5. 4.0 Right-of-way. Right-of-way, row, or land width is the width of land acquired for the road, along its alignment. It should be adequate to accommodate all the cross-sectional elements of the highway and may reasonably provide for future development. To prevent ribbon development along highways, control lines and building lines may be provided. Control line is a line which represents the nearest limits of future uncontrolled building activity in relation to a road. Building line represents a line on either side of the road, between which and the road no building activity is permitted at all. The right-of-way width is governed by width of formation. It depends on the category of the highway and width of roadway and road margins. Height of embankment or depth of cutting. It is governed by the topography and the vertical alignment. Side slopes of embankment or cutting. It depends on the height of the slope, soil type, etc. Drainage system and their size, which depends on rainfall, topography, etc. Site distance considerations. On curves etc. there is restriction to the visibility on the inner side of the curve due to the presence of some obstructions like building structures etc. Reserve land for future widening. Some land has to be acquired in advance anticipating future developments like widening of the road. Normal right-of-way for open areas. Road classification. Roadway width in meter. Plain and rolling terrain. Mountainous and steep terrain. Open areas national highway state highway. 45. 24. Major district road. 25. 18. Other district road. 15. 15. Village road. 12. 9. Built-up areas. National highway state highway. 30. 20. Major district road. 20. 15. Other district road. 15. 12. Village road. 10. 9. The importance of reserved land is emphasized by the following. Extra width of land is available for the construction of roadside facilities. Land acquisition is not possible later, because the land may be occupied for various other purposes, buildings, business etc. The normal row requirements for built-up and open areas as specified by IRC is given in table as shown in previous page. A typical cross-section of a row is given in figure. Why do we need the cross-sectional elements in highway geometric design? The characteristics of cross-sectional elements are important in highway geometric design because they influence the safety and comfort. Camber provides for drainage, frictional resistance, and reflectivity for safety etc. The road elements such as curb, shoulders, carriageway width etc. should be adequate enough for smooth, safe, and efficient movement of traffic. IRC has recommended the minimum values for all these cross-sectional elements. Thank you for watching. In next we will discuss about sight distances. For now, please subscribe, like, share and do not forget to press bell icon.